Hello, and I'm here to talk to you today about something called infinite limits. But first, it's really important to get through this idea of a limit as the denominator gets really close to zero. It's going to be the basis for almost all of this. So I want you to look at this limit right here. And if you're not sure what a limit is, remember you can graph it, you could make a table of values, or we can sometimes solve it using an equation. Let's start with the table. Go ahead and try plugging those values in. So I hope you got some y values like I just did up there. And gosh, it really seems that the numbers on the left and the numbers on the right aren't really approaching the same values there. Now, if that's true, we know that this two-sided limit does not exist. But could we look at the limit just coming from the left or just coming from the right? What happens the closer I get to zero? What happens to the y value? Well, this is what happens when you have any number divided by something approaching zero. This numerator is so much larger than whatever is almost zero on the bottom that it is getting infinitely large. Or in this case, it could be negatively infinitely large, okay? Infinitely small, I guess you would say. So it's very important to realize whenever the denominator is approaching zero, that means something's going to infinity. But wait, you might say, you recall from the beginning of this chapter that there are times where we just simply don't have limits. If the left and right-hand sides don't match, there's no limit. And if it oscillates absurdly, a very rare but real case, the limit doesn't exist. Unbounded behavior was one of those limits that we said does not exist or undefined because a limit should be approaching a number. If it ever goes to infinity, there is no limit. However, for the purposes of a one-sided limit, oops, there's supposed to be a little negative sign there. A one-sided limit, technically, this answer right here means there is no limit, but doesn't it tell us something about the function itself? So sometimes, even though there is no limit, it's really easy to actually just look at the function and tell us where is it going, what's it doing. It's describing it. So that's useful, although technically it is not a limit. So we just looked at the possibility of finding an infinite limit using a table. It's easy because on the table, your y coordinates will just keep getting larger and larger and larger without approaching any one number. They grow unbounded. Same could be if it's negative infinity. For a graph, it's just as easy. These infinite limits occur at vertical asymptotes. And remember that some graphs won't even show you the vertical asymptotes. You'll just see the graph moving along one way and then starting on the other side. So it might not be as obvious as all that, but on the left-hand side here, I see that's going to infinity, and on the right-hand side, I see it's going towards negative infinity. This is the only one of my examples here that is not an infinite limit. The x values are going toward infinity, but the limit itself is not infinite. In this case, the limit is 3. I just like to throw in these kinds of examples every once in a while. Don't be frightened. And then finally, for the last one, really, reading the graph is just as easy as it can be. On the left side, it's going up. On the right side, it's going down. Remember, these are not limits officially, but they do tell you about the graph and they do describe it. So how do you find limits when you're given the equation analytically? Here's the answer. Plug them in. But when you plug this in, okay, if I plug in -5, I'm divided by 0. That's no good. But what I want you to do is pick a number slightly less than -5. Technically, if I plugged in -5.0001, I would have something that is about -5 over 0. But you know what? It's a little bit negative. It's a little bit negative. And whenever you divide by 0, any number divided by 0, that's going to approach infinity. As long as it's not exactly 0, it's approaching 0, we know that's going to get close to infinity. So if that occurs, all we have to do is figure out is this positive or negative infinity. We have a negative number up top. We have a negative number on the bottom. You guessed it. A negative divided by a negative is a positive. Please remember, this limit is approaching infinity. That doesn't mean the limit exists. The graph is approaching that.